Greetings everyone, my name is Marcus. I am a high school student and I'm aspiring to become a quant. I enjoy math and finance and I'm recording these videos because I want to have a better understanding of certain topics and about math and all that stuff. And the reason why I'm recording this is mainly because if you explain certain topics or concepts then you gain a better understanding of it. For example, if you present something or explain something, you remember about 95% of the things that you say, whereas if you only go through your notes or read your textbook, you only read about 5% of the things. And since that I'm already recording this, I might as well share it and someone might find it useful. I plan on covering multiple topics from simple mathematics to complicated quantitative methods, and today I'll be looking at irrational numbers. First of all, before we look at irrational numbers, I would like to define what rational numbers are. Before we look at irrational numbers and rational numbers, are numbers which can be wrote down or written down in the form of a fraction, where p is equal to a whole number and n is equal to a natural number. With irrational numbers, that's not the case. For example, the irrational number 6 over the square root of 3. This can't be written down in the form of a fraction where the numerator is a whole number and the denominator is a natural number, because the square root of 3 obviously isn't a natural number. So there's a certain way how to simplify these numbers so that it'll be easier to work with them and to overall just solve problems with them way easier, and that is by multiplying them by 1. But obviously this doesn't do anything. However, if you think about it, you can rewrite the number 1 as the square root of 3 over the square root of 3, which is essentially this equal to 1 because the square root of 3's cancel themselves out, and this would be equal to 6 times the square root of 3 times the square root of 3 times the square root of 3 would be equal to 3. The entire square root is raised to the power of 2. Not the number nested in the square root, right? You're raising the entire square root to the power of 2, not the number nested. That's important to mention. In this case, you would get the same number, but you wouldn't have to in all cases. But yeah, in this case you would. So the square root of 3 times the square root of 3 is equal to 3, and these would cancel themselves out, and you would get 2 times the square. You would get 2 times the square root of 3, just like so. So that's an important thing to mention. Another important thing to mention is whether you have a, if you have a, let's say, number which is nested in a radical raised to the power of 2, or it doesn't really have to be raised to the power of 2, just if you have a number nested in a radical, it'll have essentially 2 solutions, or in other words, you'll get the absolute value of that number. For example, if you have the square root of 4, well then you're going to get the, or actually let's rewrite this. If you have, let's say, the square root of 2 to the power of 2, well then you'll get the absolute value of 2. And the absolute value of 2 can be either equal to 2 or to negative 2. Because the absolute value of 2 is 2 and the absolute value of negative 2 is also 2. And let's now rewrite our radical over here, which is essentially the square root of 4. Well then, if you plug either 2 or negative 2 into the unknown variable over here, well then you're going to get 4. And that's exactly why it's important to keep in mind that if you take the radical from a number, it's equal to the absolute value of that number. Essentially, there are 2 solutions if it is, of course, nested in a radical, a even radical, that is. Okay, so I've got a example problem over here. This is a irrational equation, And before we get to solving this, it's important to understand what are equivalent and non-equivalent changes of a equation. Equivalent changes are, for example, addition, subtraction, multiplication, or reversing the sides of an equation. The reason why they're called equivalent is because it doesn't matter how many times you do this, you will still have the same amount of solutions of an equation. So these are the equivalent. I'm just going to write E as equivalent changes of an equation. And then you can have non-equivalent changes, for example, raising the equation to the power of 2 or dividing it by an unknown variable on both sides, and these are the so-called non-equivalent changes, NE. And the reason why they are non-equivalent is that because they can change the amount of solutions the equation has, or it can change the roots of the equation. Essentially, an important thing to keep in mind is that when we are doing these non-equivalent changes of a linear equation, you have to plug in the solutions into the unknown variable to see whether they are true or false, because not all of them have to be true. You don't have to do that if you only change the equation equivalently. So let's start solving this equation. So the first thing you're going to want to do is subtracting 1 from both sides. So we're going to take away negative 1 over here, take away negative 1 over here, and that'll be equal to the square root of x plus 4 minus the square root of 3x plus 1 is equal to negative 1. And now we're going to start doing the non-equivalent changes that I've mentioned before. So what you're going to want to do now is to raise the entire equation to the power of 2. However, there's an important thing to remember here. You can't just raise the single terms to the power of 2. You need to raise the entire side of the equation to the power of 2. So essentially what that means is that we are going to do the square root of x plus 4 minus the square root of 3x plus 1 times the square root of x plus 4 minus the square root of 3x plus 1, sorry for my writing, is equal to 1. So what we did here is essentially raising the entire left side to the power of 2. So you can either write this via parentheses, or some people just like writing the exponent over the parentheses. I personally like doing it like this because it helps me with the next steps. And obviously the right side is equal to negative 1, and negative 1 to the power of 2 is 1. That's rather simple. And now we can continue simplifying the equation. Now, if we have two of these parentheses right here, you might remember, I've already made a video on this, that there's a certain formula, a to the power of 2 minus ab plus b to the power of 2 is equal to a plus b to the power of 2. So this right here, this left side of the equation is essentially the same to this. So what we're going to want to do is that we want to rewrite this left side as if it were this. So that would be x plus 4 times x plus 4, and that would be equal to x plus 4, just like so, minus 2 times the square root of 3x plus 1 times x plus 4. You can write this whole thing under one radical, you can write it under two radicals, it doesn't really matter. Plus 3x plus 1 is equal to 1. And you can put this in the parentheses if you want to, just so that it's a little bit nicer. So this essentially would be our a squared, this would be our negative 2ab, and this would be our b squared. Feel free to pause the video and to think about that for a moment. So now what we can do is that we can go and simplify our equation further. So what we can do here is that we can add the linear terms with each other and the absolute terms with one another. So x plus 3x would be equal to 4x, and 4 plus 1 would be equal to 5. And then we just rewrite the rest of the equation. And then we can just subtract 4x and 5 from both sides of the equation. And essentially, we're going to get 2 times the square root of 3x plus 1 times x plus 4 is equal to negative 4 minus 4x. Now what we can do is that we can multiply the entire equation by 1/2 or divide it by 2. It doesn't really matter which one you do. I personally like fractions, so I'm going to multiply it by 1/2. Or by 1 over 2, doesn't really matter. We can actually multiply by the negative of 1 over 2. So that'll be 3x plus 1 times x plus 4 is equal to 2 plus 2x. I'm running out of room, so I'm going to quickly get rid of this, and we're going to continue, and then we're going to continue. So now what we're going to do is that we're going to do another non-equivalent change to the equation. And essentially what we're going to get on the left side is 3x plus 1 times x plus 4 is equal to 2 plus 2x to the power of 2. If you want, you can just write 2 parentheses, the 2 plus 2x next to each other, or you can write it like this. I personally like it more the other way, but yeah, I just did it like this. Doesn't really matter. So, and if we simplify this, or if we multiply the parentheses with one another, what we're going to get is 3x to the power of 2 plus 12x plus x plus 4 is equal to 4 plus, that's 2 times 2, and that's 2 times 2x, which is 4x. Then 2x times 2 is 4x again, so that'll be 2 times 4x, which is 8x. Plus 4x to the power of 2, just like so. And now what we're going to want to do is how we're going to want to have all of our terms on the left side and 0 on the right side, because we can already obviously see that it's going to be a quadratic equation, which will be rather easy to solve. So what we can do here is minus 4x to the power of 2 minus 8x minus 4. So that's negative x to the power of 2, so that's 12x, that's 13x, that's plus 5x, plus 5x is equal to 0, because 4 minus 4 is equal to 0. We can multiply this by negative 1, so that'll be x to the power of 2 minus 5x is equal to 0. And this here is an incomplete quadratic equation. Therefore, we can just factor out x, so that'll be x times x minus 5 is equal to 0. So we're going to get two solutions. The first one is that x is equal to 0, and the second one is that x is equal to 5, just like so. So these are our two solutions. And now, as I've already mentioned before, since that we've used non-equivalent changes of the equation, we are going to have to plug in these two numbers for x to figure out which one of these is correct. Perhaps both, maybe only one. So let's do that quickly. So that'll be, you know what, I'll just write it down. So let's start with 0. So that'll be 0 plus 4, so that'll be the square root of 4, which is 2, plus the square root of 1 plus 1 is equal to 0. That's obviously not equal to 0. That's 4. So 0 is not correct. Let's try 5. So that'll be 5 plus 4, that's 9, and the square root of 9 is 3. Minus, that's 15, that's 16, minus 4 plus 1 is equal to 0. So that's 3 minus 4 is negative 1, and negative 1 plus 1 is equal to 0. So the left side is equal to the right side. So the only solution to this equation will be 5. Okay, so that's all I have prepared for today. Thanks for watching, everyone. Take care and stay safe.